Hi class. I hope you had a great Thanksgiving weekend. This module, we are going to talk about some data structure that is implemented using linked list. So we are going to talk about stacks right now. We are going to talk about queues. We are going to talk about then exception handling. So the stack and the queue both are data structures that can be implemented using linked list. I'm sure you can use other kind of way to implement them, but here we are going to, not that I'm sure, it's definitely sure that they can be implemented using other ways, for example, arrays. But in this module, we are going to talk about how to use linked list to implement them. First, what is a stack? You've seen, or you have stacks of books, you have stacks of paper, or maybe you have stacks of money. So normally you would stack one thing on top of another, like the toy in the right hand side. If you are like an adult, to put things in a stack, you put the first thing on the bottom, the second thing in the second, second to last, and then when you take things out, you take from the top. If you are an adult, I guess if you're a baby, maybe you would do it differently, or more creatively. So when you retrieve things, you retrieve from the top. We call this first in, last out, because the first item that got put into the stack is the last one to be able to come out. If we use ABC as the example, as you see, we put A first and then B and then C. So in the when it's not full because it's a linked list, it never got full until you ran out of memory. So the top one would be a C. And so when you take things out, C would get taken out first, and then B and then A. That's called first in, last out. Important concept to remember because computer people talk about this. Push and pop, exactly the same. People talk about it. So it's good that you know this keyword. That's the two basic operations of a stack. To push things in and to pop things out. I always imagine it like something that has a spring. It's like a tube that has a spring on the bottom, and so you push something in, it got clicked, and then you push another thing, it clicked and it stay, and then when you push and then things pop out. I think you've seen that kind of a mechanism before. I don't remember exactly what it is, but I know I've used it. So push in, pop out. Words that you need to know as a computer scientist also, because sometimes I think when people in the same industry share some kind of language, it's because it's easier to communicate, not that they want other people to not know what they're talking about. So hopefully in this class you've learned more than a few keywords that jargon that computer scientists use. Let's think about how we want the stack to function. So let's say we are pushing numbers into this stack from 0 to 4. We say s dot push. S is a stack. Push 0, push 1, push 2. And so 0 is in the bottom, right? 0, 1, 2, 3, 4. And then when you pop, it popped from what? It popped from 4 first. 4 is on top right now. Where top in the linked list, basically, where the head is pointing to. So what do you expect the output is going to be in this stack situation? It will be 4, 3, 2, 1, 0, because you push 0, 1, 2, 3, 4. into the stack. So let's see it, how we would implement the stack or the stack.h that we imagine that we'll be using a linked list to implement. Let's use character as an example for the data that we are going to push in this case. So the node is exactly like in the last module. There's the data, the pointer to the next node, and then we define the node pointer into something called node pointer. Class stack, private, there's only one member. It's the pointer to the head or top. It's just language, or you can use whatever word, but we use top because in a stack it's okay. And then we overload the extraction operator so that we can easily print out the stack. It's better for debugging. We have the default constructor. You always need to have one for the class. And then we have the copy constructor. We have the destructor. We have the push function that pushes one character at a time into the stack. We have a pop that will return a character. We have a boolean that talks about if we'll check if the stack is empty or not. We have a const afterward because this does not change the stack. And then you also notice that we have the copy constructor, we have the destructor, but we didn't overload the assignment operator, because I think in this case I just want to show you how to implement a stack in a linked list. I think that it's basically a copy of the copy, going to be a copy of the copies constructor. And so I happily skipped it. So let's see what we want to do in the main function. This is going to be in the demo that we are going to show you, but just thought we will go through it. We will have two stacks, S1, S2. We will have a word magic. The word's length is 5. And then from 0 to 4, we would push each character of the word magic into S1. And so we will push M first, A, G, I, C. So C will be on top at the end. So we will print it out because we overloaded the extraction function. Then we would pop each character out from S1 and then push it into S2. So then the first character that will be popped is C, right? So you push C and then I and then G and then A and then M. And so we would expect that the printing of S2 will spell magic. Actually, let me think about it. MAGC CIGM. Yes. And then in this is a test of copy constructor. So we are copying S2 into S3, and so S2 and S3 should print out the same. And then here I have a S1.pop. I want to test if we have make sure that the pop will deliver a message saying that, hey, S1 is empty and you should not pop it. Let's see the implementation of each function quickly. Default constructor. One of the most important steps actually is to assign null pointer to the variable top. If you don't do that, we don't know when the when the stack is or the linked list ended. It can be it is just not going to function appropriately. So always remember you have to set null pointer, set the top to null pointer. Copy constructor is very similar to the insert null pointer after me new data function that we wrote for linked list. But one thing we want to make sure first is that if you remember, this function only works if there are one or more nodes. And so we would check if it's empty, the stack that we are copying from. If it's empty, we just easily assign top equals to null pointer, and that's it. Otherwise, we would actually create the first node first, and then use an iterator to iterate through the whole linked list to basically implement the insert here. So I'm not going to go into detail because we did in the last module. Destructor is basically the linked list function delete all that we implement in the last module. Empty, we are testing if top is equal to null pointer and return the result. Overloading the extraction operator. I believe we have done this last time, so really push is exactly like the head insert. If you check it. Now pop is something a tiny bit different, and also I put in a try throw catch block to demonstrate, or this is an introduction to exception handling. But let's not worry about that part. Let's think about the part when it works. If it works, if it's normal, if someone didn't write a call to pop without making sure that the stack is not empty, because it's in our interface we actually talked about that pop it's like if you want to remove in the linked list, right? If you want to remove a node, you want to make sure that the linked list is not empty. And in the last module, when we implement that function, we also talked about this function is not supposed to be called. The precondition is that the linked list is not empty. And so it's the same here. To call pop, the precondition is that the stack is not empty. So if it's not empty, this is actually like a delete all, but just delete one node, just to mention it. So now let's talk about the try throw catch. If the list is, the stack is empty, then we will throw 0. We actually put the code that we want to run into a try. Anything here, any place, if it do a throw, then you can catch in the, so it's kind of like if else, right? But this is try catch. So you can catch different things. You can even catch anyways, simplest example, we are just catching an integer 0 here. So we expect an integer, and we call what we catch a e, and then if we catch it, we would say, hey, it's not allowed to call this function if only 0 elements is in the stack. Of course, we don't even need to catch it. We know that it's no element, because that's the condition that we were checking. Anyways, because it doesn't quite make sense to return anything to this function. If you do, some unexpected thing might happen, because if we put in a null character, for example, and then you don't really expect calling to pop will have a null to come out from here. Anyways, so we exit the program because we think that we really is no better way to handle this situation. So exit 1 usually means there's an error. To present this idea in a more simple form, this try throw catch block is the simplest example for exception handling that we are going to talk about. So basically, you try something, you can throw anything here. You're just going to write some code to catch it. So when you catch it, you can handle whatever you want to do with that exception. We are going to talk about this in more details, but I just thought this is an opportunity to let you see it in action. Let's do the demo. So this is exactly the same code that we had in our PowerPoint. So I'm just going to run it. So after, oh, sorry. So after S1 is all pushed in, you see the word magic is reversed, and then we pop everything out, so there's nothing inside. Now S2 has magic, and then because S3 is a copy of S2, so it also has the magic inside. When we popped the S1, because S1 is empty, so it the throw got caught, and then the error message is printed out. So to recap what we talked about in this video, we've talked about what is a stack, we talked about how to implement stack using linked list, and we talked about the most basic example of try, throw, catch block for exception handling. Next, we are going to talk about queues. See you soon.